What are real numbers? We say that all the rational numbers and irrational numbers are called as real numbers. So what is negative of an irrational number? That number is also a irrational number here. For example, if I want to write negative of root 5, sum or difference of a rational number and an irrational number is an irrational number. In this lecture, we will discuss about real numbers. So class, let us start with definition of real numbers. What are real numbers? We say that all the rational numbers and irrational numbers are called as real numbers. That means rational numbers together with irrational numbers are said to be real numbers. That is, a real number is either rational or irrational, right? For example, we can see over here 2. Now 2 is a rational number because it can easily be expressed in the form of p by q form, right? Where p and q are integers and q is not equals to 0. So yes, the first number is a rational. The second one, minus 3 upon 2, is also a rational number because it is in p by q form where p and q are integers and q is not equals to 0. After that, you can see 0. 0 is also a rational number. Next, 1.5. 1.5 is also a rational number because it can be expressed in p by q form. After that, it is square root of 2 or root 2. So here class, why this is irrational number? Because when we find out its value in decimal form, the decimal expansion will be non-terminating and non-recurring decimals. And we know that all the non-terminating and non-recurring decimals are irrational numbers. The next example you can see, here in the angular part, there is a small 3 we have written. So what it is representing? It is cube root of 5, right? The order is equals to 3 over here. So we say it as cube root of 5. Now cube root of 5 is also an irrational number. Why? Because when we find out its value in decimal expansion, its value will be non-terminating and non-repeating decimal, right? In the next number, you can see in angular part, we have written a small 5. That means here the order is equals to 5. That means we can easily read out this number as fifth root of 11. So this number is also an irrational number. So class, all the numbers, that means rationals together with irrationals, are called real numbers. Also remember one thing, that all the numbers that can be represented on number line are called as real numbers, right? So all these real numbers can easily be represented on number line. Now class, let us move on to operations on real numbers. But before that, let us see some important points. Over here, the first one is negative of an irrational numbers. So what is negative of an irrational number? That number is also a irrational number here. For example, if I want to write negative of root 5, so how can we write it mathematically? Simply by putting a minus sign before root 5. So this is negative of root 5, minus root 5, right? So this number is also an irrational number, right? Minus root 5 is an irrational number. The next one here says negative of minus root 21 is equals to root 21. So here class, negative of minus root 21 is how much? It is actually minus of minus root 21, right? And we know that what is minus minus? When we multiply one negative by another negative, minus minus is plus. Hence, the final answer will be root 21, right? So here class, negative of a negative irrational number is a positive irrational number, and also, yes, it is going to be irrational number, right? Now, let us see some operations. The first one here says sum or difference of a rational number and an irrational number is an irrational number. So here class, you can see we are going to find out addition and subtraction of two kind of numbers. One will be rational and another will be irrational. Now when we do so, what will happen? The answer, right? The final answer will be what kind of number? The final answer is going to be irrational number, right? What we are going to get? We are going to get irrational number. So let us see some examples over here. For example, 1 plus root 2. Now here the first number is rational. The second number is irrational. So when rational and irrational are added together, the final answer that we get, the final answer 1 plus root 2 is an irrational number, right? So here class, we cannot simplify it further. It will be written as it is. 1 plus root 2 will remain 1 plus root 2 only. And this complete number, whatever the value we are going to get, is non-terminating and non-recurring decimal. Hence, we will say that this is finally the addition is giving us irrational number, right? After that, the next example you can see irrational number. Root 11 is an irrational number. From it, we have subtracted one rational number 7. So when irrational minus rational happens, then the final answer will be of what kind of number? The final answer will be root 11 minus 7. You can see we cannot solve it further. We cannot simplify it further. It will remain as it is. Root 11 minus 7, root 11 minus 7, right? So what kind of number is this? This number is actually irrational number. So yes class, always remember, if we are finding out sum, that means addition, or if we are finding out difference of rational and irrational, right? One number will be rational, another one will be irrational. Then the answer is always irrational number, right? The next one over here is product of a non-zero rational number and an irrational number is an irrational number. So class, in our previous point, we discussed about addition and subtraction, and now here we are taking product, that means multiplication. But very important part over here is non-zero rational number, very important. So as we have mentioned over here that what all rational numbers we are taking all the rational numbers excluding 0. We are not including 0 in our multiplication. Then what will be the answer? Always remember, non-zero rational number multiplied by an irrational number, the answer will always irrational number. The answer will give us an irrational number. For example, let us see 5 into root 2. Now, it can be easily written as 5 root 2, right? We can exclude this multiplication sign and simply this number can easily be written as 5 root 2, right? So, the product is 5 root 2. Hence, here you see the first number is rational, the second number is irrational. When we have multiplied rational and irrational, we are getting the answer as irrational, right? This number 5 root 2, what kind of number this is? This is an irrational number. Also class, you can see what kind of rational number we have written, non-zero rational number. We do not have to put 0 here, right? Suppose if we put 0, right? Suppose if I not write over here that we need to take non-zero rational numbers, right? We can take any rational number. So product of rational and irrational need not to be irrational always. Why? Because you see, when we multiply irrational number 0 by any irrational number, the answer will be 0. And we know that what kind of number we have got in the product? It is rational. This number belongs to rational number, right? So 0 into root 2 will give us 0 and the answer 0 is belonging to rational number, right? So that is why it is very important to show over here, to write that here we will take always non-zero rational numbers, right? The next one you can see root 11 multiplied by minus 3. So here class, how we can simplify it, how we can write it in a more simpler way? It is going to be minus 3 root 11, right? Again, we have excluded this multiplication sign. Rational number is always written in the first place, right? So minus 3 in the first place followed by root 11. As there is no sign in between, that means they are in multiplication, right? So this number minus 3 root 11. Minus 3 root 11 is what kind of number? Irrational. So class, I hope you have understood that whenever you do product of non-zero rational and one irrational, then what kind of value we are going to get? The answer is going to be irrational always, right? Moving on to the next point, sum, difference, product and quotient. Now we have taken all the 4 mathematical operations, right? Plus, minus, multiply and divide of 2 irrational numbers need not to be irrational. Now both the numbers are going to be irrational with us. Then what happens? Let us see. So when we see sum, that means addition. You see, root 3 when added to negative of root 3, right? Root 3 is irrational. Negative of root 3 is also an irrational number that we have discussed earlier. So 2 irrational numbers are getting added. Can you see the answer over here? The answer that we are getting is what kind of number? It is a rational number. So here we say that not always we are going to get the addition of irrationals and the irrationals, right? It can be rationals as well. After that, you can see root 2 plus root 3. Now, this cannot be simplified further. It will be written as it is. So, here irrational plus irrational is equals to irrational. So, sometimes you can get rational and sometimes you can get irrational, right? But not always. Need not to be an irrational number always. Now, let us see subtraction. Again, root 7 minus root 7. The first one is also an irrational number. The second one is also an irrational number. So, when we subtract two irrational numbers, we can get rational in some times, right? So, here you can see the answer is 0 as it is rational. Now, root 6 minus root 5, you see what is root 6 minus root 5? We can write it as it is. No change at all, right? No simplification. So, root 6 minus root 5 is equals to root 6 minus root 5. So, what kind of number is root 6 minus root 5? Yes, class, this complete number is actually irrational number, right? So, here we can see irrational minus irrational will give us irrational. So, class, we have seen over here that in addition also we can get rational or irrational. In subtraction also we can get rational or irrational, right? Now, moving on to product and quotient. So, when we multiply, what we will see? Let us see. So, root 2 into root 18. So, how we can multiply the two irrational numbers, class? We can easily write these two numbers inside one radical sign as square root of 2 into 18, right? So, here class we can easily write root 2 into root 18 as in a common radical sign 2 into 18, right? Now, this doesn't happen in addition or in subtraction. We do not do this type of simplification in addition or subtraction. This type of simplification is done in multiplication or in division, right? We can easily put both the numbers inside one radical sign because the order is same. This is also square root, this is also square root. So, square root of 2 multiplied by square root of 18 is going to be equal to square root of 2 into 18. So, what is 2 into 18? We know that 18 2s are 36. Hence, it is square root of 36. So, yes class, we can easily take this 36 out of the radical sign in the form of 6. Why? Because 36 is square of 6, right? So, here class, initially we multiplied two irrationals. Root 2 is an irrational number. Root 18 is also an irrational number. So, when we have multiplied irrational into irrational, the final answer we are getting 6, and we know that the number 6 is a rational number, right? Next example, you can see root 3 into root 7. So, root 3 into root 7 will be equals to how much? Yes class, root 3 into root 7. As the order is same, both are square root. Therefore, we can write both the numbers inside one square root in multiplication, right? So, what is 3 into 7? 3 sevens are 21. So, the final answer that we are getting is root 21. And what kind of number is this? This is an irrational number. So, yes class, here we saw that when we multiply two irrational numbers, right? When we multiply two irrational numbers, we might get rational, we might get irrational, right? The next one is the division form. Root 48 upon root 3. Again class, we can easily write this division inside one square root only like this. You see, it was written root 48 in the numerator and root 3 in the denominator. But what we did, we have made one single square root, and inside that single square root we have written both the numbers 48 upon 3. Now, when we solve it, we know that 3 ones are 3 and 3 16s are 48, right? So, here finally we are getting root 16, and root 16 can easily be solved further, right? So, here the final answer of root 16 will be 4, because we know that square of 4 is equals to 16. So, here the final answer coming is 4, and what kind of number is this? It is rational. The next example you can see over here, root 12 upon root 7. Again, a common radical sign we have put, a common square root we have put. Inside that we have written both the numbers 12 and 7 in upon form. So, root 12 upon root 7 is actually equal to square root of 12 upon 7. This numerator is an irrational number. The denominator is also an irrational number. So, when irrational number is getting divided by irrational number, in this case, what kind of number we are getting? We are getting an irrational number. This number is irrational, right? So, here class also we have seen that when we multiply or when we divide two irrational numbers. What kind of numbers we have picked? Both irrationals are there, right? So when we multiply or when we divide, we might get rational sometime and irrational sometime. Here also we might get rational sometime or irrational sometimes, right? So need not to get irrationals always, right? We might get rationals also. So these are some important points that we have to remember while calculations. Now moving on to one question. Consider the following statements, and after reading these statements we need to answer that which of the above statements are correct, right? That means we need to identify what are the true statements and what are the false ones. So the first statement here says that product of two irrational numbers is an irrational numbers. So are we going to get irrationals always when we multiply two irrationals? Yes class. What is root 2 into root 2? Right? What is root 2 into root 2? Root 2 into root 2 will be equals to how much? Both are irrationals. So when we multiply them, we can easily write root 2 into 2. And as there is pair of the factors, so here I can easily take 2 outside. So the first number was irrational number, the second one was irrational number, and the final answer is coming over here is rational, right? So here class we saw that not always we are going to get irrationals, right? So here this is going to be the false statement. The next one, product of any two rational numbers is a rational number. Now this is a true statement. Why? Because what property it is showing over here? The closure property of rational numbers. In closure properties of rational numbers in multiplication, right? What we have seen over there, that whenever we multiply two rational numbers, the answer is always a rational number, right? So this is a true statement, closure property. Then the third one says product of any two natural numbers is a natural number. So yes class, this is also true. You can pick any two natural numbers. The product of those two natural numbers will always be a natural number. So this is also a closure property. When two natural numbers are multiplied, the answer is always in natural number. So yes, natural numbers are closed under multiplication. So this is also true. So here class, which of the above statements are correct? They are second and the third one. So option 2 is going to be our correct answer. Statement 2 and statement 3 is the true statements. Moving on to the next question. Which of the following statements is incorrect? Now class, read the questions very carefully. What language of the questions are there, right? So here we need to find out incorrect statements. That means we need to identify the false statements. So let us see. Let us read these statements. There can be a real number which is both rational and irrational. So here class, this is false statement. Why? Because we say here we can say that real number can either be rational or irrational. In our definition, we have written this way that real numbers can either be rational or irrational, right? One particular number cannot be both. If I write a number over here, root 2, now this number is irrational only. This number cannot be called as rational, right? So a real number can either be rational or it can be irrational. It can never be both, right? This is wrong. So this is a false statement, right? So option 1 is our correct statement, correct answer. But here let us discuss all the other options. Sum of any two irrational numbers is not always irrational. So here class, this is a true statement, right? Not always an irrational. Why? Because we have seen that when we add root 2 in negative of root 2, so how much we are going to get? Yes class, plus minus is minus. So root 2 minus root 2 is going to be 0. And what kind of number is 0? 0 is a rational number. So here class, we saw that addition of two irrational number is not always irrational, right? Sometimes we get 0 as well, which is a rational number. The next one you can see, for any positive integers x and y, x is less than y, says that x square is less than y square. Now here what kind of numbers we have to pick? Positive integers. So what are positive integers class? Starting with 1, then 2, 3, 4 and so on. So all these type of numbers are called as positive integers. Now here we need to pick two such integers such that x is less than y, right? One integer will be less than the another one. So when we put square on both of them, Here, let us suppose if x is equals to 2 for the third part, right? If x is equals to 2 and or 3 suppose, and y is equals to 4. So here we can easily say that x is less than y, right? As per the given condition. Now when we put square on x, it will be 3 square and that is 9. Also y square is equals to how much? 4 square, that is 16. So now we can easily compare 9 and 16. We can say that yes, 9 is less than 16, right? X square is less than y square. So this is also a true statement. The last one says every integer is a rational number. Again, a very true statement. All the integers are rational number. Whether they are positive integers, whether they are negative integers, or whether it is 0, all the integers can easily be expressed in p by q form, where p and q are integers and q is not equals to 0. Also, p and q are co-primes. So yes class, all the integers are rational numbers. So class, second, third and the fourth statements are true. The first one is false, hence option 1 is going to be our correct answer. I hope you have understood it. Practice more questions. Thank you.